This video was brought to you by the ILC. Hello there once again. Welcome back to our Exam 2 review series. This time we'll be doing problems 5a and 5b, where we are given two exponential equations and we are asked to change them to inverse form. When you have exponential equations, the way to change them to inverse form is to use a log or a natural log, represented by ln. Now, if you have base e underneath a number or something else, that's the time to use ln, and we're going to use it on both sides. So we'll have ln of e squared equals ln of x. Now, the ln and the e are two things that we call inverse functions. That means one of them always cancels the other one out. So if we cancel out this ln and this e like this, what we have left is 2 equals ln of x. This is the inverse form of the equation we started with. Now, if you don't have e, and instead have the number 2 or something like it, we would use a common log, and that common log must be a base of 2, written like this, log 2 on both sides, with the 2 in a subscript. So when we write that, we'll have log base 2 of 2 to the 5th, log base 2 of 32. Now, log base 2 and this 2 base exponential here are also inverse functions. That means log base 2 and the 2 base cancel out, leaving only the 5 behind. And on the right side, we'll have log base 2 of 32. And this is the inverse form of the second equation. So when you start with an exponential equation and you switch to inverse form, you should have an ln or a log left behind. Now let's look at the reverse situation in problems 5d and 5f, where we are given logarithm equations and we are asked to change those to inverse form. To change a logarithm equation to inverse form, we use an exponential. And the exponential we use must match the base of the log we start with. So if we have log base 3 to begin with, we will use a 3 exponential. So let's begin by saying 3 equals 3. The left side of the equation we start with will be placed above the 3 that's on the left. The number 2 on the right side will be placed above the 3 on the right. So what we'll have is 3 raised to log base 3 of 9 on the left side. On the right side, we place the 2. Now, just like last time, we have a pair of inverse functions. Because we have a 3 exponential and a log base 3 inside of the box I just drew, because those are inverse functions, they both cancel out. So look what we have left. On the left side, we have just the 9. And on the right side, we have 3 to the second power. This is the inverse form of what we began with. You can tell it's inverse form because we started with a log and ended with an exponential, since that's the inverse of log. Let's do the same thing with this natural log of x. If you have a natural log, we are going to use a base e exponential. Let's write e equals e. On the left side, we raise it to the natural log x power. On the right side, we raise it to the 5th power. Now, this base e and this ln are inverse functions. They cancel out. Let's have a look at what's left. On the left side, we have x by itself. On the right side, we have e to the 5th power. Once again, we do have an exponential. Thank you for watching. We'll see you again soon.